we're now inviting Jason Wong from Illumio, the system architect and engineer, to come on board. Give us a few seconds. I know you are definitely in the right virtual room. I do apologize. This is, like I say, we are, I wouldn't say this is our first time doing webinar. Hello, Jason. Hi, how are you?
Hello. Yeah, I'm having trouble hearing.
I can hear you properly.
There's no sound coming through. Let me see.
I can hear you, Jason.
Hello.
All right, Jason, take a few minutes to figure out his audios and stuff. My colleague Christine is basically helping him. Jason, can you hear me? But you're right. Sometimes with technical things, it does happen. Do bear with us. Do bear with us. Hello, Jason. You hear me now? No. Okay.
Hello. Yeah.
Hello. We can hear you.
To be some issue on my end. Let me see.
Yeah,
I really can't
because
hear,
you're using iPod like me, so you might basically have to change your mic.
Just give me a moment. Sorry.
Audio.
Yeah, I know you can hear me, but I can't hear myself, or I can't hear anyone from the chat. Let me just make sure that it's interesting. Let me just, I tell you what. Okay, tell you what, let me try without my Bluetooth and we'll see if this is better.
All right, can you hear me now? Thank you, Glory. I don't think Jason can hear us at all, but Jason, you mute your mic now. Your mic is muted, so no one can hear you now.
Can you say something? I can just want to make sure that I can hear something.
Jason, can you hear me? I'm talking now.
No, this is
you can't
not
hear?
good.
Okay. But everyone can hear you. No problem. Thank you, Eugene. So I think probably Jason experienced some issue. Hello, I can see your son. Hi. That's okay, not a problem.
Evan, come. Evan, all right. Please, I'm
so cute.
Evan, just give me a moment. Okay. Sorry about that. Okay, I'll tell you
problem.
what, let me do this. Let me share my presentation and then we'll just go ahead. I can't hear you, that's fine. And then let's use the chat window.
Hello,
all right, let's.
Hello.
let's do.
Hello.
All right, so just give me a moment.
If you share your screen, then we can see your screen. You have to share your presentation, the applications.
All right, so you can see my screen right now. So I'm just going to change to, yeah. Okay, please let me know if you can see my screen right now.
I can see your screen, but anyway, go ahead.
It's okay? All right, okay, good.
Yeah, but
thank you everyone,
anyway.
and I apologize for that small hiccup. You know, we have done this test before, and then somehow things just, you know, break on the day itself, and it does happen. Apologize for that, but I'm happy that you can see me over here, and most importantly, you can see what I'm presenting. So hi, good morning everyone. So my name is Jason, and I'm the systems engineer here with Illumio. So today I just want to kind of like, you know, take about 20 minutes to kind of share with you how we help our customers really around security segmentation, right? So we have been very familiar with segmentation today, but the way we do it really is through data center visibility, right? It's about gaining insight into your data center and to be very effective in security segmentation. So I don't want to take more of your time out of this, so let's get straight into it, all right? So let's see what we're going to cover today, right? So I'm going to really break this down into three parts, really. The first one is really around the problem statement, right? So why security segmentation? And what are some of the challenges that our customers shares with us or has shared with us that they have encountered as part of trying to be effective or trying to get to a state where they are confident enough that they are protecting their critical assets or their crown jewels. Then, of course, I would share with you about the how. And these are not, you know, these are not Illumio statement or anything. It's really the fact, right, of how this problem being solved, right? So one of the strategy is through decoupling, all right? And then finally, I'm going to talk about how Illumio manages this problem, right? So what's the solution looks like, how Illumio puts in places all these controls to be able to then, you know, resolve the problem statement. Okay, so these are the three things that I'm going to kind of cover that, right? So let's get straight right into it. Now, why security segmentation? So that's the first thing we're going to talk about. And, you know, segmentation has been around for a long time. So it's nothing new. It's, you know, organizations have used various methods to do segmentation. Traditionally, it's always been, you know, through the network. And there's nothing wrong with that method. In fact, until today, every single organization certainly has some form of segmentation in place. All right. So as a safeguard to your critical assets in your data center. None of the organizations really like to do it more than they should. But really the drivers for some of these segmentation initiatives or the reasons why they approach segmentation so seriously is because it's driven primarily through some form of compliance requirements or regulatory requirements. All right, so it could be a SWIFT requirement, right? Audit requirement for especially for the banking industry, PCI DSS or even high trust or HIPAA, and any one of these regulatory requirements mandate that the organization needs to be able to demonstrate that they put in sufficient security controls to be able to fulfill the requirements of, you know, segregating their critical crown jewels away from the other assets that they have inside the data center. Okay, right? So it's really primarily driven through some of these mechanisms today. So in your organization, I want you to start thinking about why is segmentation important for you For some organizations, you know, if there's no regulatory requirements, sometimes it could be a best practice. You have recently done a pen test, and one of the recommendations from your auditors could be that, hey, some of your workloads that are residing in the same infrastructure as some others, you know, they could technically be talking to one another, right? And so we want to have the ability to isolate these workloads. All right. Okay. So let's take a look. Just give me a moment. So let's take a look about, sorry, just let me back out a bit. So let's take a look at what segmentation is and why is it important. So you can see here an analogy of segmentation, right? So with segmentation, without segmentation, you notice that if there is you have a submarine, and when there's a breach in any parts of the submarine, what you notice very quickly is that, you know, the water fills up the submarine and it kind of brings the whole thing around. Now, submarines are never, you know, designed this way. They always have an outer hull, a shell, hard shell, and then they have compartments in between. And the whole idea is to compartmentalize various sections of the environment in such a way that if any one of these compartments gets breached or they get filled up with water, it's not going to bring the entire submarine down. And you can apply the same analogy to your data center as well. Okay. And of course, I like to, you know, given this situation now here in Malaysia, with the movement control order, that you have all of these isolations right in place. The whole idea is to really minimize the possibility of spread, you know, of the virus or any of these threats or breaches, right? In such a way that it can be easily contained and the threat can be easily minimized. Okay. All right. Sorry, I was told that I'm showing you the, okay, all right. So thanks for letting me know. Okay, so now this is the full screen view. All right, okay. Yeah, I'm just seeing the notes. Okay, all right, thank you so much. Now, this is a very common way for breaches to spread across your environment. And it's, you know, we often attribute this to a bad actor, right? And it often case happens this way. We will have, you know, some of your non-so-critical assets. It could be from a vendor portal where you have your third-party vendor coming in and accessing some of your authorized systems. And then from there, you know, a malware basically managed to compromise a communication path and exploit those paths and get into your internal servers. And from in there, they can basically move across freely within your data center and then start infiltrating and gathering data and then exfiltrating it out to the other environments. And this is a very, very common approach. And today what we are seeing as well is that there's also a lot of insider threats, right? So not necessarily involving third-party components. It could be resulted from an internal breach, and it does not necessarily mean there's a bad actor. It could just mean that someone could be negligent in their in the way they manage the environment, and so maybe they left some password somewhere, or you know, the servers are not hardened to the way it's supposed to be. So there is just all of these various reasons that could have introduced a path to which a breach could have taken place. And so if you do not have segmentation strategies in place, then these threats could easily maneuver itself very quickly around your data center, right? Okay, so this is the reasons, you know, why segmentation is so important in your data centers. And I'm pretty sure all of my audience over here today would recognize that as well, because that's why you have segmentation today already in place. Now, but what are some of the challenges today with the traditional network segmentation? Okay. And this is something that our customers have shared with us, right? So we're going to see some points come up over here. This is something that we have spoken to our customers, and we try to understand what it is that they have tried to do and why they find it so hard to achieve, right? And they tell us that it's getting harder. The fact that it's getting harder, it's not because they lack of solutions or they lack of tools to solve this problem. But the fact is that today their environments are getting larger and larger. They have many operating system instances across on-prem and public cloud, and makes them even harder to manage all of these environments, right? Now, they share with us because of this ever-growing environment that they have that spans across different cloud environments, whether is it on-prem or public cloud, or even whether they have physical virtual machines or even containers. One of the biggest challenge for them is around application visibility. Now, not knowing exactly what's taking place within the data center makes it very very hard for them to be able to put in proper guardrails or controls, all right, to determine how applications should be communicating. So this is the first thing that they shared with us. In fact, this is the key component that we hear all the time. The second one is around heterogeneous environment. Now, we recognize that most organizations don't only have one particular system, right? You don't only have a hypervisor environment from one vendor. You probably could have physical servers, some hypervisors or multiple hypervisor environment, whether it's from VMware or from KVM, or even from Nutanix, right? And you may have some workloads that now you have pushed out to the public cloud, whether it's on Azure, on AWS, or Ali Cloud, or G Cloud, wherever these environments might be. Okay, so this makes it very, very hard to put in controls now, because every single one of these has different control points, right? Sorry. Oops. Okay. Sorry. Okay. The perils of working from home. There's so many things that's just going. Okay. Now, and then the third one is really around having very complex security policies. Now, the fact is that you have no application visibility and your genus environment means that you need to start putting in different policies in place. And because you have no idea what's happening, you start to figure out the most complex way of writing security policies and putting them into the environment and praying and hoping that nothing breaks your application. Okay. Finally, of course, it requires a large effort for implementation. So these are just some of the key reasons why our customers shared with us that they felt that this is getting out of control, at least for them from an operational standpoint, and the fact that they just cannot get this act together. Okay. Now the thing is this: they have been trying many ways, and we say that the existing approaches fall short. Now, I'm not suggesting that it's a bad way or a bad mechanism to address segmentation, but it just falls short, right? Means that you take a lot more time, you may not be aware, and it may introduce some security gaps within the environment. So what are some of the existing approaches? So one of them that we are all familiar with is network-based segmentation. So this is really around using whatever network tools that you already have today in your environment. You bolt on the security components onto it using firewalls or your network devices, right? ACLs, to basically perform some controls, to carve out zones, segments, network segments for security segmentation, right? And the other piece is, of course, SDN. So, of course, organizations today they want to automate some form of their network, and they largely move to SDN-based segmentation. Now, the fact is that whether is it SDN or network-based doesn't change the fact that all of these policies somehow, the control somehow is within the network. And so what are some of the common challenges that we see from here? The first one is that you have multiple administration points. the fact that you have a network on-prem and you have one in the public cloud, for example, and you have different tool sets over there, introduces all these different administration points, makes it so complex for you to put something that is cohesive and coherent across your entire network. And the second thing is that policies are all typically tied to IP addresses. And so what it means is that once you change an IP address, just one among thousands of your workloads, you start to introduce complexities because you need to start, making changes into your network devices to kind of update it, to introduce these new IP address changes as well into the environment. Okay, so every time there's an IP address change, these changes needs to manifest itself across all your different devices in the environment. Okay, and today we often see, right, your applications are today not conveniently located within your physical network boundary. All right, so you have applications that are spread across multiple data centers across different locations, and some of them even in the public cloud on-prem. All right, if you want to put in some kind of control, you have to route all your traffic to a single choke point to be able to have that controls in place, right? And of course, there are inconsistent segmentation capabilities across different devices, right? Your environment may have some very legacy proprietary systems running on AS400, AIX, Solaris, while you have some modern systems as well running on Windows or Linux. And then you have some, real microservices kind of approach for your applications running on containers. And all of this has different segmentation requirements and different capabilities. And so when you try to mishmash all of this together, it becomes really, really complex. So these are some of just the common challenges that we see. Okay, now this is what the industry sees as the way to kind of address the challenges, right? And we have a concept called decoupling. I'm going to kind of share with you. Now this you must be very familiar with today. The picture on the left-hand side, which is really the highway that you see today on Malaysian roads. All right, I don't think there are any cars there today, probably on certain roads only. But really, today, network admins creates their network path. It's really around performance, right? It's all around connecting bits so that your servers can communicate in the best possible way, the quickest way, the fastest way, for the best performance, right? So that's all around network connectivity. You're building the best path for your applications, so your users can always get connected to your applications. All right. So you want it to be fast, you want it to be flexible, and you have, on the other hand, an opposing idea where you have your security team trying to bolt on of these security controls because they want to put in some form of controls onto your network lane in such a way that the traffic now needs to be inspected, needs to be governed, needs to be controlled. They need to know who is getting in and out of the network so they can identify whether there is a potential bad actor, or they can stamp out the bad traffic from the good ones, okay, before it enters the network. So what you're trying to do is that you are trying to bolt on security controls onto the highway. And so what happens is that your fast highway now becomes a choke point now, where all of the traffic needs to go to a singular place. This is, I believe, in Malaysia, so you'll be very, very familiar with this. These are all your highways. Of course, you have your touch and go, but the fact is that many of us still rely on this way to pay our tolls. All right, but what happens if we can decouple this? And this is where I come around, your smart tag and your touch and go, right? We can decouple the toll collection, all right, from the highway, where your vehicles can move as fast as the vehicle can go. All right, so basically it's transporting bits as fast as it needs to go in the network. Security controls is independent or is abstracted away from the network infrastructure, meaning that it's not bolted on. All right, you don't have to route all your traffic to a single point to basically have that inspection taken place. So where's the inspection? Now the question back to you is that where do you put your smart tag device in your vehicle, right? So you put that device into your car. So the concept is very similar, right? You put something into your vehicle so that when your vehicle goes through any of these, booths or these gantries, the toll collection can still take place. You can go into your car park, you can still be deducted, your toll collection can still happen, your car park fees can still be deducted from your SmartTag device. So all of this can be done independently of the network architecture. So what this does is that it allows the network traffic to remain free-flowing, and you can do your segmentation independent of the network. All right. So this concept sounds very cool. And so this is the concept of decoupling, but this requires an architectural shift. So what it means, you need to decouple the network architecture from the security segmentation component. So essentially we are saying that, hey, all right, put your network architecture aside, do segmentation, the security segmentation separately from your network architecture design. All right. And what this allows us to do, if you think about it, right, this allows us to write policies independent of whatever design you have in your network. You don't even have to worry every time your network team makes some changes. Your security policies or your security constructs still remain as is. Meanwhile, when you make any change to your security constructs, nothing in your network needs to be changed as well. All right. Okay, makes sense? I hope this makes sense, right? So what are some of the principles for a successful security segmentation practice, right? So there are few ways to overcome this. And we already talked about some of the common challenges, and this is really addressing those common challenges. The first thing that we need is a way to group your applications, your workloads, right? So I have a diagram over here. I just kind of want to show it to you. And you can see over here, right? So you have all these workloads residing in various parts of the data center. And, you know, they can reside in the same host or different hosts, you know, as virtual machines, as containers. But they could represent different applications. But today, there's no good way for us to be able to logically group them. And the way we logically group all these applications is by the ability to be able to label them or give them some form of labels. All right, to be able to identify the role of the workload, right? What does it do? Is it a web server? Is it an application server? Is it a web server? Is it a database server? All right. Which application does it serve? So you have so many web servers, right? Is it part of my HR application? Is it part of my finance? Is it part of my Swift payment infrastructure? Is it part of my logging infrastructure, right? Is it core services? Okay. Which production? So I have a number of these HR applications, but some of them is in UAT, is in staging, is in production, is in development, right? So the different environments that it exists in. Finally, the location, right? So very similar to Google Maps, right? I can determine that this one happens to reside in Kuala Lumpur. This one is in my CyberAttack data center. This one happens to be in my public cloud infrastructure. So when I have all this logical grouping, think about it from a mapping perspective. It looks very similar to Google Maps, all right? Where you have your building, you have your street names, you have your smaller street names, and you have your different floors and all of this, right? And so this brings us to the next thing, right? It's really around the map. So now when you have all your building labels all in place already, then we start to build all of these communication lines in between all of these buildings. What it means is that we start to build a map of showing you connectivity between your hosts. So this is not your typical network topology, right? So it's not showing you how your switches are interconnected, where all your traffic are going to host communication. All right, what we are interested in is to see communication between two different hosts or multiple different hosts. All right, so you can see from here the map, we can show you all the different traffic lines that's taking place from server to server. And this is very fundamental for how we're going to solve the challenge of segmentation. And finally, a way for us to be able to model the policies, right? So today, you know, when you write any security policies, you push it down to the physical infrastructure. One of the biggest constraints is kind of like I mentioned just now, you kind of pray and hope, you know, it doesn't break your application. I've tested, I've gone through all the change management, it doesn't break my applications. So to be able to model, to test the policy, all right? Test the policy means that I'm going to push down all of my policies, right? So that it gets enforced somehow, but it doesn't break my application, right? So I don't want, you know, a mechanism that requires me, you know, so much effort in, in building it. And when I push down the policies, I have no idea whether it's going to make or break my application. The idea of testing is very, very critical for what we need to achieve, right? And finally, before once everything is being tested and approved, then you can go into this state called enforce, where traffic that do not conform to your security policies gets dropped to the floor, right? So this is something that you want to achieve as a final outcome, but the thing is that you don't want to get there necessarily too quickly, okay? Because you don't want to break your applications. Now, the thing is, like, once the policy is decoupled from the network, then you can do a number of things, all right? You can do things like environmental segmentation, okay? Because now you are no longer worried about how your network behaves. I can say that my prod should never talk to my dev. I can describe that as a security policy. I can do application segmentation. I can say that my finance application should never be talking to my HR application. My Swift payment infrastructure should always be isolated from I can make all these determination, security policies determination, independent of the network. I can do tier-based segmentation. I can say my web tier can only communicate my app to my DB, right? For my specific application. Finally, of course, I can look at even process segmentation. I can be very specific in saying that, wow, I do not know what ports my applications are communicating over, but I certainly know the process that they are using. So what I can do is that I can say that, hey, please allow my servers to, my application service to be accessed through mysql.exe or sql.exe, all right, irrespective of whichever ports that they communicate over, all right? So you can achieve a number of segmentation strategies independent of the network. And so this is very, very key, okay? Now, this is how my application dependency map looks like. Now, when you have all of this in place, you will start to notice that I have a logical grouping of my environment. So this is a view of how this looks like. When we do a demo for you, once you're interested, then you get to see this in real time. So you can see the role of the applications, where there's a load balancer communicating with my web tier, right? You can see all the traffic flows. And these are host-to-host communication. From a segmentation perspective, this is all that is required. And I can see them logically grouped together. I have my ordering application, I have my HR application over here. In fact, I have two HR applications. My HRM application, I have one in production and one in staging over here, right? They are the same application, but they are in two different bubbles because they represent application in two different environments. One is in production and the other one is staging. Okay, so finally we have also a point of sale. So you can see all these traffic lines going across all this environment, and really helps us to determine the kind of security policies we can put in place to control the traffic that we write. Okay, put in place. All right. So the way we solve this problem now, this is the last piece of my conversation here. I'm just going to share with you how Illumio solves this problem, and it's something called the Adaptive Security Platform. So you can see over here, I have illustrated here a number of my workloads that can sit across my data center, in my cloud environment, wherever they might be. I place in a small little piece of software. So this is a lightweight software, all right, which is about 5 to 7 megabytes in size. We call it a virtual enforcement node, right? I'm going to explain a bit more what it does. But really, it runs in user space. It's not in line to traffic. So think of it like a print driver, or just an application service, right? Where you just install it. It doesn't require a server to reboot or anything like that. So it runs in user space. And all it does is really around trying to understand what's happening within the operating system, within the guest operating system. So it's trying to listen to the connection state inside the operating system, trying to understand the port, the protocol, the processes, the IP addresses, everything that's happening within the operating system. It sends that telemetry, as we call it, back to the second piece of software. Now, this is the central brain. It's called the policy compute engine. This is really where the magic happens. The software, the ones on the left, the virtual enforcement node, that's passive software. It has no ability to do enforcement, no intelligence whatsoever, right? So everything happens in this policy compute engine. This is where the map is being drawn. So once we have the telemetry, it sees all the host communications, it draws out the map for you. All right. So once the map is being drawn, then you will be able to then write policies, right? So these are not your firewall rules, but these are really a statement describing how your applications should behave. When I say behave, means that should my web server talk to my app server? If it does, then describe it that way, right? Web can talk to app, maybe over port 8080. App server can talk to DB server over port 5432, right? So when you describe this relationship for your application, the policy compute engine itself will make all the calculations, all right? The L3, L4 calculations, it will translate all of this into native L3, L4 firewall rules. All right, so all these firewall rules are the rules that is needed to fulfill that policy that you have described earlier. Right, these rules gets pushed down to the individual operating systems that you see on the screen here. All right, so every one of these operating systems will inherit a number of firewall rule sets. All right, but these rules are not enforced by Illumio. So Illumio has no ability to do any enforcement. That's why we call it a virtual enforcement node. It takes all of these firewall rules and it places it into the native host-based firewall. So in the Windows environment, it has something called the Windows filtering platform. Really, that's the filter for Windows. In Linux, that will be IP tables. In your AIX and Solaris platform, is something called IP filters. They're all the same. What they do is that they filter traffic as they come through. But the rule sets are now being automatically programmed by Illumio. Now, Illumio becomes the control plane for all of these enforcement points, right? If you can now start to take a look at it. So we build a map for you, and we allow you to describe naturally how your application should behave in such a way that we compute all of this automatically, all the firewall rules automatically for you, and push it down to the individual operating system instances. Okay, so how Illumio works, the solution, right? And finally, so our customers have shared with us, right? They use Illumio because we are a lot faster to deploy, and faster to achieve the outcome they're looking for. So not the 2 years or 3 years to get into segmentation. By the time they reach the 3 years, they again have to constantly keep changing, the tool sets or the approach again. It's a lot easier, as you can see the way I've described it over there earlier. By using the map, we make it very easy for them to write segmentation policies. It's a lot less expensive. Obviously, there's no hardware involved. The operational cost is significantly reduced. Obviously, there's also the capex reduction because there's no hardware components that are required. And it's a lot less risky, right? For the fact that you can model the policies, you can test it, meaning that you can actually see what the outcome would look like. You can know if your application would break as a result of having these policies in place without actually breaking your applications. So this is what our customers share with us, all right? And so thank you so much for your time, and sorry for that little, I'm happy to take any of the questions over here if you do have any. And I do apologize. I think there's something wrong with my speaker over here. So I certainly need to see from the chat if there are any questions.
Jason, there are a couple of questions there. I think most of the participants can hear me. He will basically take a couple of minutes just to read the questions, and then he'll answer it.
Okay.
But unfortunately, we only have time for 2 questions. Go ahead.
All right. So, yeah, so what happens if a bad actor managed to compromise one of the machines? So some of these machines administered by administrators with privileges, right? So he or she will be able to manipulate the machine's host-based firewall and try to infiltrate the other machines as well, right? So my answer to this is very simple, is that the bad actor will not be able to go very far having Illumio in place beyond the machine that was compromised. And the reason is because Illumio programs both ends of every connection. And what this means is that if an outbound connection is allowed from server 1 to server 2, let's say over port 8080, a corresponding rule at server 2 to permit an inbound connection from server 1 over port 8080 is also in place, right? So that means there's always rule sets at both ends of the connection or at the servers, right? So as such, the bad actor is restricted when they are trying to move laterally from within the bridge machine. Okay, so hopefully that gives you an idea why this is fundamentally a very, very important approach using Illumio to try to address segmentation. So you're not only just putting your controls at one end of your perimeter, you're putting it everywhere. So in certain cases, this is how what we determine as putting a micro perimeter around every single one of your workload instances, right? So I hope that this answers the question. All right, so I noticed that Mish has also helped me to answer some of the questions on the chat group. So thank you very much. So in a typical complex organization, what's the best practice to create or maintain the logical map for decoupling, right? So as I described earlier, obviously with the map, there's a concept of labeling, right? So you want to ensure that you have proper labels to describe your application. So the contextual information for the application is very, very important. And we get this information from a number of various sources of truth. This could be a configuration management database, so we can get it from a CMDB, right? So you may have something that you have already documented your assets in maybe a ServiceNow environment. Or perhaps you keep it in a spreadsheet, right? And we can get it from there as well. Some customers use host naming convention. So from their naming convention, from the server's naming convention, they can actually derive what the server does, which environment it exists in, the application name, and the function of the workload. Sometimes we can get it even for Active Directory. All right, so from wherever this environment where we can get this information, we can extract this information into the policy compute engine. We call it ingest it in, and we allow you to then automatically label all this environment. So it's very important to note that while this is an effort that is required to be able to label your infrastructure correctly, but it's an automated process, meaning that it's not something that we want you to do it as a manual effort, right? So we can actually pull in all this information from different sources, give it a proper context. Okay. Can Illumio capture all the traffic flows in NetFlow format? The short answer to that is yes, certainly. Now the thing is this: when you place a van, when you place a software into every single one of these operating system, it has already collected telemetry information. That means it's collected all of this information from within the guest operating system, right? So it has enough fidelity. It has the most amount of fidelity within the environment to be able to determine how the hosts are communicating. There are places that we cannot put in our software agent. Now, in those places that we cannot put in our software agent, what we do is that we can ingest traffic flows from switches, from your network devices, whether it's S-Flow, NetFlow, IPFix, right? So we can actually gain all of this insight into some of these places where we cannot place our software, and then we can actually gain that insight as well. All right. So certainly we can do that. Okay. There's also a question around during COVID-19 challenges from working from home requires accessing through VPN. Yep, this is a very good question. And shared folders. How to ensure security and isolation of network could be monitored. Right. So especially working from home today, many organizations actually, kind of punch in a hole, if you will, to your network. And what I mean by punching a hole, when you create a VPN tunnel into the network, you are essentially providing the users access into corporate resources. And sometimes what happens is that sometimes that introduces additional risk to the environment where, threats from all these external environments could potentially get into your corporate resources, right? And so Illumio works very, very well in these situations. And we work in the same premise of protecting or isolating your most critical crown jewels. And the approach is fundamentally the same. You put a ring fencing policy, you create micro perimeters in your infrastructure, and you put in policies to determine which users from this VPN environment, for example, if you know the subnet, the VLANs, wherever they might come from, you can write policies to control who and how they can actually enter into your application services, right? So once you put in all these ring fencing policies, you are not required to write any of these security firewall rules, right? All of this will still be computed automatically by the policy compute engine, and will push it down automatically to all of the servers that you have put all these micro parameters around, and then it controls how this traffic will actually enter into my systems. So that's a very, very good use case. In fact, if you're thinking about controlling user access from wherever they are, right? Whether it's from the internet, from the homes, from the public cloud infrastructure into your corporate environment. Okay.
Great. Thank you so much, Jason. Thank you for the great presentation. And you do have actually a lot more questions coming in. Unfortunately, we can't answer all of them. So we basically will take these questions and answered by your team later on to all the attendees.
Thank you.
Thank you so much. And we will have to basically move on to the next sessions. And we're going to basically go, we invite you to another room again. You go to the schedule on top of your left-hand side. You click on going to that room on session number 3.